Okay, so this is the start of Unit 2 for higher chemistry, and your first topic is alcohols. So there is some National 5 recap in this, and obviously some parts of the higher. So, alcohols. So starting with your Nat 5 recap, you need to know that alcohols contain the functional group called the hydroxyl group, and it is the OH group here. For example, you can see it in methanol here. You've got your CH3 and OH at the end. So this part is your functional group here. This is where any reactions would happen. Okay, so for your alcohols, your general formula is CnH2n plus 1 OH, and this is all stuff we learned at National 5 level. Okay, we need to know that alcohols can have more than one hydroxyl group. So for example, here we've got two hydroxyl groups. You can see them here, 1, 2. This is called a diol, and remember, mon, di, tri. So 3 hydroxyl groups going to be called a triol, and there's an example here of it. Okay, this molecule here is actually called glycerol. And you'll come on more to that later in Unit 2. Okay, and remember, alcohols all have the general ending anol ending. So for example, if it has one hydroxyl group, you would say where that hydroxyl group is present within the name. Okay, so onto our higher stuff. Okay, so higher content goes a little bit further into alcohols, and you need to be able to describe what a primary, secondary and tertiary alcohol is. You have to be able to identify these also. Okay, so first of all, we'll start off at the start. So primary alcohols, okay, they can be identified where the hydroxyl group is. So in a primary alcohol, a primary alcohol is the one where the carbon atom containing the OH group is bonded to one other carbon atom. So for example, here you've got your hydroxyl at the end here. So you look at the carbon containing that hydroxyl group. So you're going on to this carbon here. And that is bonded to one other carbon. Okay, so the carbon containing the hydroxyl group is bonded to one other carbon. Another example of this could be something like this. You've written all your hydrogens. Here we've got our hydroxyl group here. So I'm going to underline that. Our hydroxyl group, the carbon attached to it is attached to one other carbon. So we're looking at this carbon here because that's the carbon the hydroxyl was attached to. So this carbon here is attached to one other carbon. This makes this a primary alcohol. Okay. A quick way of identifying a primary alcohol is the OH, so the hydroxyl group, is usually on the end carbon. Okay, so here it's on an end carbon, here it's on an end carbon. Okay, so primary alcohol, when the carbon atom containing the hydroxyl group is bonded to one other carbon atom. And moving on to secondary. Okay, so this is very similar, just ever so slightly different. So a secondary alcohol is one where the carbon atom containing the hydroxyl group is bonded to two other carbons. Okay, so here in this example, here we can see the hydroxyl group. We're looking at the carbon that contains the hydroxyl group, so it's this one here. Okay, this carbon is bonded to two other carbon atoms. And here we're going to underline the functional group, so we've got our hydroxyl group. And it's all about the carbon containing that hydroxyl group. So we're going to talk about this one. And this is bonded to two other carbon atoms. Okay. Quick way of identifying it. It's in the middle of the chain. So your hydroxyl group is going to be in the middle of the chain. Okay. On to our last one then. Tertiary. So tertiary alcohols is an alcohol where the carbon atom containing the OH group, so a carbon atom containing the hydroxyl group, is bonded to 3 other carbon atoms. So here's an example here. We've got our functional group, we've got our hydroxyl group, and then it's all to do with the carbon that contains that. So we're going to circle this carbon. Okay, so this carbon here is bonded to 3 other carbon atoms. 1, 2, 3. So this is a tertiary alcohol. Another example here, we've got our hydroxyl group, I'll underline it, and it's a carbon containing the hydroxyl group. So this is the carbon we're talking about. This is bonded to 1, 2, 3 other carbon atoms, therefore it's going to be tertiary. And finally, a quick way of identifying these for your tertiary alcohols is your hydroxyl group is opposite a branch on the same carbon. Okay, so opposite a branch, here we've obviously got a branch here, and we've got a branch here. Okay, so your tertiary alcohols, for a quick identification, it is opposite a branch on the same carbon. Okay, so looking at these then, we've got some shortened structural formula here. Okay, so basically what I want to do here is I'm going to name whether these are primary, secondary or tertiary. So an example here, what I like to do is I like to draw it out. So we're going to have CH3 to COH up here to CH3 down here. CH2, CH3, and add in all your hydrogens. I like to draw it out straight. That's because, or it's full structural formula even, because that's the way you guys are most comfortable with it coming from National 5. Okay, so here we're looking at it. We've got our functional group here. We've got our OH group, and remember it's a carbon containing your OH group, so we're going to talk about this carbon here. So this carbon is attached to 1, 2, 3 other carbons, which makes this a tertiary alcohol. Okay, and if you notice, your hydroxyl group is opposite a branch on the same carbon. This one then, so we've got, if you draw it straight out, we've got CH3, CH, CH3, CH2, CH, CH3, I'll put all my wee H's in, CH2, CH2, OH. Put my hydrogens in. Okay, so underline your functional group. You've got a hydroxyl group at the end, and it's all about the carbon containing that. It's going to be this carbon here. This carbon is attached to 1 other carbon atom, so this is going to be a primary alcohol. Okay, and last but not least, down the bottom, and again, you're just going to draw it out straight. So we're going to have CH3, CH, CH3, down here, CH2, CH2, CH, OH, CH2, CH3, and add in all your hydrogens. I know there's a lot of them. Okay, so our hydroxyl group is here. Okay, and it's all about the carbon containing that hydroxyl group. So we're going to circle this carbon atom. And this carbon atom is attached to 2 other carbon atoms. So this is going to be a secondary alcohol. Okay, so as you can see, my tertiary is opposite a branch. My primary is on the end carbon. And my secondary, is in the middle of the chain. Okay, so properties of alcohols. Okay, you know that alcohols have this hydroxyl group, it is an OH group, okay? And because of that OH, the hydrogen bonded directly to the oxygen, okay, it allows this alcohol to hydrogen bond. Okay, so first of all, alcohols are polar molecules. Polar molecules because there's going to be a difference in electron negativity between your oxygen and your hydrogen. Okay, so your oxygen is going to be delta negative and your hydrogen is going to be delta positive. Okay, so because of this, and you have oxygen present bonded straight to a hydrogen, you can have your alcohols can participate in hydrogen bonding. Okay, what you need to remember is hydrogen bonding is your strongest type of intermolecular force. Okay, and remember that hydrogen bonding is in between two different molecules. Okay, so two different molecules, not within one. And remember, your intermolecular forces, another name for them, are van der Waals. Okay, so due to these alcohols being polar molecules, we need to remember like dissolves like. So your polar alcohols can interact with water molecules. Okay, and here you can see that this is an alcohol molecule, this is ethanol, and you've got a water molecule here. You've got your difference in electron negativities in each, which causes them to be polar. Okay, water is polar and your alcohol is also polar. And here you have this interaction through intermolecular bond, which is hydrogen bonding. Okay, so your alcohols are soluble and miscible with water. Okay, so there's no layer formed between the alcohol and the water when you put alcohol in the water, and this is because we know like dissolves like. So polar dissolves polar and non-polar dissolves non-polar. So these both are both polar, therefore polar dissolves polar. Okay, and talking about the melting and boiling points lastly, alcohols have a higher melting and boiling point than other molecules that are of similar molecular mass due to this difference in electron negativity due to the OH. Okay, so because my alcohols can participate in hydrogen bonding, okay, the strength of that bonding has to be overcome when you're melting and boiling this molecule. Okay, so you need to remember that hydrogen bonding is your strongest type of intermolecular bonding. Okay, and the stronger the van der Waals or intermolecular force, I'll just put IF, okay, the higher the melting and boiling point. So here we've got a strong intermolecular force, a strong van der Waals, therefore of molecules of similar molecular mass, your melting and boiling points are going to be increased. Okay, so your viscosity is also related to your intermolecular forces. Okay, remember viscosity is basically how easy a substance pours. We sometimes think of it as how thick a substance is. So for example here we've got water, it pours easily, it's got low viscosity, whereas syrup, as in maple syrup, pours slowly, it's got a high viscosity. This is all to do with the intermolecular bonding, okay, and the intermolecular bonding, the stronger that bonding is, the higher higher viscosity it's going to have. So this basically the thicker it's going to come across. Okay, so the larger force or the stronger force, the larger viscosity. Okay, and in alcohols, it's important that you know the more OH groups, so the more hydroxyl groups present, the more viscous the substance is. So for example, your glycerol here, again, as I've said, you'll come onto it, you'll do quite a lot with glycerol. Your glycerol has a high viscosity due to the 3 OH groups here. Remember, 3 OH groups is called a triol.